Hi everyone. We are going to keep talking about circles because we're still in Module 5, and today we're going to talk about some theorems about chords and arcs. So first of all, the first situation we're going to look at is if you have a circle with two chords that are crossing somewhere in the middle of that circle. And I said here, it actually breaks the circle up into 4 arcs. Now, we used this phrase before, but we call these intercepted arcs. So basically, think about this picture right here. We have a circle, and there are two chords crossing in the middle. The first chord is QS, and the second one is PR. And I even numbered, it breaks it up into 4 angles. And each of those angles has an intercepted arc. So like the first angle, which angle number 1, the one kind of on the left there, has the red intercepted arc, PQ. And angle 2 on the top has the black intercepted arc, QR. Now, just so you know, these angles are just angles. They're not inscribed angles, they're not central angles, they're just angles. So the intercepted arcs in this picture are the 4. There's 2 black and 2 red. You can see them. There's QR, RS, SP, and PQ. Now, also notice what we've created is something we talked about a long time ago, vertical angles. Whenever you have 2 lines crossing, when you have that X shape, you get 2 sets of vertical angles. So number 1 and 3, the left and right angles, and numbers 2 and 4 are also vertical angles. So here's our theorem about intercepted arcs. Each angle, and also one other thing we know about vertical angles are congruent. So whatever angle 1 is, angle 3 is the same. And whatever angle 2 is, angle 4 is the same. So if you want to find those 2 measures, either angle 1 and angle 3, or angle 2 and angle 4, each one of those angles is going to equal half of the sum of the 2 intercepted arcs. And that's why I colored them the way I did in the picture. That's why you have 2 reds and 2 blacks. So basically, if I take those 2 red arcs on the left and right, and I measure them in degrees, arc measure, if I take those 2 measures, I add them up and divide it by 2, that's going to tell me angle 1 and also angle 3, since they're equal. And if I do the same thing with the black arcs on the top and bottom, if I add those measures up and divide by 2, it'll tell me what angle 2 and angle 4 are. Okay, so for our first example today, we're going to solve this picture right here for x. Now I moved the picture around, but it's the same concept. It's 2 chords crossing in the middle, and I asked you to find angle x, which is one of the angles in the middle. Now by our vertical angle theorem, even though I didn't put it in the picture, this is also an x right here. Those 2 angles are the same, they're equal. If you find one, you find both. And if you know our theorem that we just learned, this is actually a very simple question because I gave you both of the intercepted arcs. For the angle x that was marked in the picture, its intercepted arc is arc AD right here. Now for the other x, which wasn't marked in the picture, which I added, its intercepted arc is BC right here. So our new theorem says if I take those 2 arcs and add them up and divide it by 2, that's going to tell me what the angle is. So I just do 32 plus 54 divided by 2. 32 plus 54 would be 86, and 86 divided by 2 would be 43. That's the answer to the question. X is 43 degrees there. And that's going to work every time in a circle. If you have 2 chords crossing in a circle, and you want to figure out what one of the angles is, you have to know both intercepted arcs. You have to know the intercepted arc for the angle you're looking for, and also for its vertical angle pair. But if you do, you just add those 2 up, you divide by 2, you get your answer. Okay, new theorem. If you take the chords and you extend them, so let's say instead of just drawing line segments that start and stop on a circle, they keep going. They're lines that keep going on the outside of the circle. And they cross outside of the circle instead of the inside of the circle. You get the exact same theorem, but you subtract the arcs instead of adding. Now here's a picture that goes with that. So in this picture right here, instead of having two chords that cross inside of the circle, I have two chords that didn't cross inside the circle, but when I extend them, they cross outside of the circle. Now one little note here before I talk more about this picture. There's a name for that. If you have a line segment that starts and stops on the edges of a circle, we call that a chord. If you extend it so it keeps going forever, we call it a secant. So those are called secant lines. And now let's go to the theorem. So we have two intercepted arcs again. We have this bigger one here from C to D. And then we have this smaller one here from B to E. So if I want to find this angle right here, maybe I'll call it X, then what I can do, it's the exact same theorem, but you subtract instead of adding. Instead of adding those two arcs and dividing by 2 to find the angle, you do the bigger one, which is the purple one, minus the smaller one, the red one, and then divide by 2. So let's turn that into an example. So I look at this picture, and even though I've changed the lettering and kind of moved the picture around, it's the same picture we just saw. You have two secant lines, or two chords that I've extended so they meet outside of the circle. Now, one of the arcs is very large. It's right here, all the way in here. This is the purple one, all the way around. That's 175 degrees. That's one of the intercepted arcs. Now, the other one, which I did red in the notes earlier, is this shorter one, which is 57. So to find that angle, I said solve for the missing angle, which is the question mark there, angle TGE. What I'm going to do is I'm going to take the bigger angle, 175, subtract the smaller one, 57, and then divide that by 2. So what I get is 118 divided by 2, or 59 degrees. So these are not hard problems, but you got to make sure you know when to do what. You got to know when, like that first example from today, when we add the arcs and divide by 2, or in this picture right here, when you subtract the arcs and divide by 2. Okay, one last question. I'm going to do the same thing I've been doing all module long, where it's like I give you a question, we kind of do it the normal way, and then I flip it around backwards. So now what I've done is I've given you the angle. The angle is 44 degrees. I also gave you the smaller arc. The smaller arc right here is 65 degrees. Now the bigger arc is the question mark, and actually there's another interesting thing about this question. One of the lines from R to P is a secant line. The line from R to S is actually a tangent line, not a secant line. But that's okay because you still have intercepted arcs. What's going to happen is the arcs are going to start and stop at the same place. So your two intercepted arcs both start at point S. The purple one goes from S to P, that's the one we're trying to find, that's the question mark. The red one goes from Q to S, that's 65, and the angle is 44. So even though it's a tangent instead of a secant, once you realize that, it's the same question we just did, but work backwards. So let's set it up the same way. I started off by taking the big one. The big one is the purple one. I don't know what that is, so I'm going to call it X. And then I subtracted the smaller one, the red one, that was 65. And then I divided it by 2. Now remember, last time I was just figuring it out. I just did the number minus 65 divided by 2 and got the answer. This time that's the X. I don't know what it is, so we need an equation. So what I'm going to do is I'm going to say after I take X, subtract 65 and divide by 2, the answer is going to be 44. Because see, I already know what the answer to the question is. It's that 44 degree angle up top. So now instead of just figuring it out or plugging it into a calculator, I actually have to solve for X. So the first thing I want to do, if I want to solve for X, I want to get rid of that 2 underneath the X. I'm going to do that by multiplying both sides of the equation by 2. Remember, a fraction basically means divide. So X minus 65 over 2 means divided by 2, and we can cancel a divide with a times. So this 2 cancels with this 2, and just leaves the X minus 65. And on the right-hand side, 44 times 2 would be 88. And then one more step to finish solving for x, I just need to cancel out the minus 65 with a plus 65. That's gone. X equals, that would be 153. And that was what I asked you to find. The question mark was the x. So that purple arc is 153 degrees. Not quite as easy as the last example. And that's really been one of our themes for Module 5, is we learn these theorems, and first I give you an easy question where you just put the numbers in and maybe type it into your calculator and you're done. But then I flip the question around on you. I say, well, what if I don't give you the arc? What if I give you the angle and ask for the arc? Then can you set up an equation and actually solve for x? That's an important skill too.